Hello, math students. Welcome back to our module on statistics. This is lesson 6, and it is called Describing Distributions Using the Mean and the MAD. Our goal for today we will apply our knowledge of mean and MAD to describe numerical data distributions. The question that I want you to think about in this lesson is, how can we use the mean and the MAD to help us make decisions related to a data set? So the best way that I would say that we are going to incorporate the use of the mean and the MAD to make decisions about a data set is to try it with an example. So under the Show What You Know section, we're going to try a little practice with gift baskets. Below are dot plots of a number of caramels in gift baskets from 2 candy shops. Which candy shop would you want to get a gift basket from if you liked caramel? Use the mean and the MAD to answer the question. So if we're looking at our dot plot, basically the first thing that we have to do is we have to figure out what the mean is so that we can then figure out what the deviations are. And we need to do that for both shop A and shop B. So we're going to use our table that I introduced you in the last lesson. And so let's start with gift baskets from shop A. So it says the number of gift baskets, and then what you have to do is the number of caramels that are in them. So in one gift basket, we have 0 caramels. In the second gift basket, we have 0 caramels. In the third gift basket, we have 3. In the fourth gift basket, we have 3. In the fifth gift basket, we have 5. And in the sixth gift basket, we have 7. And so that's what our distribution is of the number of caramels that we have in each basket. So what we're supposed to do now is we're supposed to find the mean of that data set. And if you remember the process of finding the mean, you take all of the data points and you add them together. And then you divide them by the number of data points that there are. So we have 0 plus 0 is 0, plus 3 is 3, plus 3 is 6, plus 5 is 11, plus 7 is 18. And we have 6 gift baskets, so then I have to divide that by 6. And I get 3. So 3 is the mean. So this whole section together has a mean of 3. Now it's saying the deviation from the mean. So remember how we find that is we take the number of caramels and subtract the mean. So we have 0 minus 3 equals a negative 3. We have 0 minus 3 equals a negative 3. 3 minus 3 equals 0. 5 minus Oh, no, we have to do 3 again. 3 minus 3 equals 0. 5 minus 3 equals 2. And 7 minus 3 equals 4. And then we have to take the absolute value of each deviation. So this deviation is negative 3. And to take the absolute value of that, the negative 3 is 3 hops from 0, so it would be 3. The absolute value of negative 3 is 3 hops from 0, so that would be 3. 0 hops from 0 is 0. 0 hops from 0 is 0. 2 hops from 0 is 2. And 4 hops from 0 is 4. Okay, and now we're trying to find the mean absolute deviation. So again, what you have to do is you have to add all of these data points up. So 3 plus 3 plus 0 plus 0 plus 2 plus 4 equals 3 plus 3 is 6, plus 0 is 6, plus 0 is 6, plus 2 is 8, plus 4 is 12. And then we divide those by 6 because there are 6 of them. 1, 2, 3, 4, 5, 6. And 12 divided by 6 equals 2. So now we know the MAD for this gift basket from shop A is 2. Okay? So that wasn't too hard doing that, right? You just find your mean and then you figure out your MAD from the mean. So now we're going to do it again, and this time, instead of doing shop A, we're going to do shop B. So the mean on this one was 3. The mean absolute deviation was 2. So now gift shop B. Number of caramels in the first 3 baskets is 2. In the fourth basket and fifth basket, it is 3. And from the last basket, it is 5. So I've got all the data points for this one. And so remembering what you do with this is you take all of the data points, add them together, and divide by the total number. So we have 2 plus 2 plus 2 plus 3 plus 3 plus 5 equals 2 plus 2 equals 4, plus 2 equals 6, plus 3 equals 9, plus 3 equals 12, 13, 14, 15, 16, 17. Make sure I did that right. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yep, 17. And then we have to divide that by 6 because there's 16 data points. And 6 goes into 17 2 times, and that would be 12. And then 17 minus 12 is 5. And so we get 2 and 5 sixths as the mean. So this whole thing right here equals 2 and 5 sixths. So now if we remember this right, we take 2 minus 2 and 5 sixths, and then we do 2 minus 2 and 5 sixths, and then we do 2 minus 2 and 5 sixths, and then we do 3 minus 2 and 5 sixths, and then we do 3 minus 2 and 5 sixths, and then we do 5 minus 2 and 5 sixths. Okay, so now I need to do that math over here. And if we have 2 minus 2 and 5 sixths, what we actually have is negative 5 sixths, negative 5 sixths, negative 5 sixths, and then 3 minus 2 and 5 sixths. Well, what I could do is I could take 3 and cut it into 2 and 6 sixths minus 2 and 5 sixths. And by doing that, we'd say 6 minus 5 is 1 sixth, and 2 minus 2 is 0. So this equals 1 sixth, and this equals 1 sixth. And then we have to do 5 minus 2 and 5 sixths. So I could change that into 4 and 6 sixths minus 2 and 5 sixths. And I get 1 sixth, and I get 2. So this would be 2 and 1 sixth. So then we take the absolute value of negative 5 sixths, gives you 5 sixths, hops away from 0. Negative 5 sixths is 5 sixths hops from 0. Negative 5 sixths is 5 sixths hops from 0. And then I take the absolute value of 1 sixth, and that is 1 sixth. The absolute value of 1 sixth is 1 sixth. And then the absolute value of 2 and 1 sixth is 2 and 1 sixth. And then if I remember right, we take all of these deviations and add them together. So we have 5 sixths plus 5 sixths plus 5 sixths plus 1 sixth plus 1 sixth plus 2 and 1 sixth. So I could do 1 sixth and then plus 2. Okay, so this means that we have 5, 10, 15, 16, 17, 18. 18 sixths plus 2, which 18 sixths is actually 3, plus 2 equals 5, okay? And then I'm supposed to take that and divide it by 6, and 5 divided by 6 is 5 sixths. So that's the deviation for shop B is 5 sixths, because when you take 5 and you put it in the house and you divide it by 6, then you would get 5 divided by 6, which is 5 sixths, okay? So the mean for this one is 2 and 5 sixths, and the mean absolute deviation is 5 sixths. So now what we're trying to decide is what would be a better place to buy the gift basket from, because you're trying to figure out what is the deviations from the mean. And over here, we have a deviation from the mean of 1 whole, whereas over here, we have a deviation of 2 wholes. So if you're looking at that, that really does tell you a lot about the gift baskets, because again, shop A's, this is shop A's data, I forgot we wrote it up there. So shop A's data says the mean is 3, the mean absolute deviation was 2. So that means that each point only deviates from the mean by 1 whole, whereas the mean here is 2 and 5 sixths, and the deviation over here is 5 sixths, which if you look at the difference between those two, it's 2 full whole number deviations away from the mean. So for me, I would say shop at shop A because there are less deviations from the mean number of caramels. So basically what you're trying to understand about this is if you have a huge deviation as opposed to a small deviation, then you will always want to choose the small deviation because the mean is telling you that the average amount of chocolates that have caramel in them is 3, and yet the data points on shop A only deviated 1 whole away from 3, whereas shop B, they deviated 2 whole deviations away from the mean, which means that you have less caramels. Okay, so which shop and why? Shop at shop A because there are less deviations from the mean number of caramels, and so you will get more chocolates that have caramels in them at shop A than you would at shop B. So we're using the MAD to help us determine which one would be the better place. Okay, so going back to our goal, today we will apply our knowledge of mean and MAD to describe numerical data distributions, which we did. We even got to decide which store to shop at, and we chose shop A because it had fewer deviations than shop B, because shop A only had 1 deviation, 1 whole deviation, and shop B had 2 whole deviations. So that's how we were able to use the MAD to help us. The question that you were supposed to think about in this lesson is, how can we use the mean and the MAD to help us make decisions related to a data set? You use the mean and the MAD to determine what would be the average and then how far away from the average you are. So we figured out the average for both shops, and then we figured out how far away we were from that average, and that helped us decide which one we wanted. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.